Today we're going to take a look at our second day of exponent rules. So you can title your notebook, Exponent Rules, Day 2. So as a reminder of the ones we went over yesterday, we said if you had x to the m times x to the n, that you add our exponents. We said a second one that we had was if you had x to the m to the n power, that we multiply those. So x to the mn. And then the third one we went over yesterday was x to the m over x to the n equals x to the m minus n. So we talked about those three yesterday. Today we're going to talk about a couple more. And so I'm going to leave a little space at the top that we will add these to the top here. So we'll have all of our exponent rules. But we're going to take a look at one that, like, what if we had x to the 7th over x to the 7th? Well, we know that is equal to 1, because it's the same thing over there. It's x to the 7th over x to the 7th. Same thing divided by the same thing is 1. But we also know that our rule is to subtract. So x to the 7 minus 7, which is x to the 0, is 1. So we know anything to the 0 power has to be 1. The second thing that we're going to take a look at is what do we do about negative exponents? And we talked a little bit about this yesterday, that if we have a negative exponent, we switch what side of the fraction it's on. So that becomes 1 over x to the n. So we could write that rule over here, x to the negative n, 1 over x to the n. And if it's on the bottom, if x to the negative n is on the bottom, we switch it so it's on our numerator. So to make an exponent positive, we switch what side of the fraction it's on. So what we're going to do next is we're going to just take a look at a couple problems using all these rules, different rules. And so our goal is always no parentheses, no negative exponents, and one of each base. And we'll talk a little bit more when we get to multiple variables what that means. But if you have a base of x and a base of w, you should only have one base in each spot. So the first one that we're going to look at is, let's say we have 5 to the n times negative 4n squared. So we could say we have a number base and a base of n. So let's take our numbers here and let's multiply them together. So we have negative 20. And then if we take our n's, we have n and n squared. So we have n cubed. So that's a review from yesterday, and so is one like this. If we have negative 3x with a cubed on the outside, we have to cube everything on the inside. So we have negative 3 cubed times x cubed. And negative 3 cubed, negative 3 times negative 3 is positive 9, times negative 3 is negative 27, because again, this is negative 3 times negative 3 times negative 3. So we have negative 27x cubed. Now let's see if we can figure out some negative exponents. So let's take a look at 3x to the negative 4. And at the same time, we're going to look at 3x in parentheses to the negative 4. So again, if we have a negative exponent, we switch what side of the fraction it's on. Now keep in mind we only switch what the base is. So this negative 4 is attached to the x. So this would become 3x to the positive 4. So the 3 does not move. It just is, it stays on the numerator. The x is the one that switches. Where if we look at the next one, we can think about it, like I always think parentheses first. So this is 3 to the negative 4, x to the negative 4. So they're both negative exponents, so they'll both move. And then 3 to the 4th, 3 times 3 is 9, times 3 is 27, times 3 is 81. So we have 1 over 81x to the 4th. So I want you to notice the difference there. They both flip because that -4 is a power to both. Whereas this number 3, it's just the x that flips because that's where the -4 is with. So now we're going to take a look at some that get a little bit more complicated. So let's say we have 5a cubed over 15a squared. Well, the first thing I think about is distribute those parentheses. So this is just really 5a cubed over 15a squared. So let's deal with our numbers first, 15 and 5. Well, that reduces down to 1 over 3. And a, now we take a look at our a's. A cubed and a squared, there's more a's on top, so we have a squared. And you wouldn't have to write the 1. You could just put a cubed or a squared over 3. So the next one, let's say we have 6x to the -1 divided by 4x to the -1 cubed. So again, the first thing I tell myself is to get rid of those parentheses. So 6x to the -1, 4x, the 3 just goes to the parentheses, so the -3. Well, now we have negative exponents. So 6 and 4, those stay because their exponent is just 1. X to the first, we'll flip that to the bottom. X to the -3, we'll move that to the top. And now we can simplify. So our numbers first, 6 over 4 reduces down to 3 over 2. And then if we look at our x's, we got x cubed and x to the first, so there's more on top. So we have those 2 more on top. The next one we're going to look at, let's see, we have 3p squared to the 4th power, -6p cubed. So again, first thing we want to do is get rid of those parentheses. So we have 3 to the 4th power, p to the 8th power, divided by -6p cubed. Well, 3 to the 4th. And again, if you're unsure on those, we can always jump on here. 3 to the power of 4. So we have 81. So this is 81p to the 4th. And is 81 divisible by 6? Let's see, -81 divided by 6, 13.5. And one thing about Desmos, you can hit that fraction key on the side there. So do you see that right on the number 1? Right next to 1. So -27 over 2. And then if we look at our p's, there's 1 p left on top. And sometimes people ask, well, the negative was with the 6, and now you put it up on top. You can put it out in front as well, as long as there's just one negative. The whole number is either negative or positive. And the last two we're going to look at get a little bit more complicated. So let's say we have -8w to the -6x to the 3rd divided by -2w to the -1 to the 4th power times x to the 6th. So again, first thing I always do is get rid of those parentheses. So the top is good, so I can leave that as -8w to the -6, x to the 3rd. But now the bottom, so we got -2 to the 4th, w to the -4th, x to the 6th. And well, -2 to the 4th, -2 times -2 is 4, times -2 is -8, times -2 is 16. So I'm going to erase that and say, well, that's positive 16. And now I'm going to get rid of the negative exponent. So notice I said exponents. -8 over 16, well, -8 is, that's still negative, but I move the exponent, so that stays. So w to the -6 flips. X to the 3rd stays. And now if I look at the bottom, w to the negative 4, it has to move to the top, x to the 6th. And this is where, don't know why this is not writing right now. Uh-oh, this could be a problem. Let me try this. Whoa, let me try this one more time. Something happened here. Maybe if it's just on that part of the screen. So let's see. Negative 8 over 16, w to the 6th flipped, w to the 4 flipped, x to the 3rd stays, x to the 6th flipped. And again, this is where I was talking about those bases. You want one of each base. Well, our number, so negative 8 over 16, that's negative half. Now, if we look at our w's, there's more w's on the bottom, so w squared. And now we look at our x's. There's more x's on the bottom, 3 more, so x cubed. So again, it all depends upon where there's more is where we put that. So 4 and 6, there is more w's on the bottom, 2 more. X's had 3 and 6, there's 3 more on the bottom. And you're done, you'll notice there's just the number, and then we have one base of w and one base of x, so we're done. And the last one we're going to take a look at here. We're going to look at a long one and see if we can break it down. So negative 6, w to the negative 3, v to the 4th to the negative 2, 10 w to the negative 2, v to the 8th. So again, I always do parentheses first, so negative 6, this would be w, negative 3 times negative 2 is positive 6, 4 times negative 2 is negative 8, divided by 10 w to the negative 2, v to the 8th. Well, now I'm going to deal with the negative exponents. So negative 6 over 10 can stay. W to the positive 6 stays. I have v to the negative 8 on top, so that goes to the bottom. W to the negative 2 goes to the top. V to the 8th, that stays on the bottom. Well, now I can reduce some of these things. So negative 6 over 10, negative 3 over 5. Now if we take a look at 6 and 8, oops, that's a v and a w. So if we just look at our w's, they're both on top. So that would be w to the 8th, v's on the bottom, v's to the 16th. Now one side note here, I want to double check something when entering it into Delta Math. So let's take a look at this one here on Delta Math real quick, just to make sure we're okay with how to enter it on there. So again, if I write this one out, we got negative 4, k to the negative 3, v to the 4th to the negative 1, 20 k to the negative 2, v to the 8th. So we distribute first. So negative 4, k to the 4th, v to the negative 4, over 20, k to the negative 2, v to the 8th. Move our negatives, so negative 4 over 20 stays, k to the 4th stays, v to the negative 4, that moves to the bottom, k to the negative 2 goes to the top, v to the 8th. So now if we simplify it, negative 4 over 20, so negative 2 over 10 it reduces down, so negative 1 over 5. Our k's are on top, so we have k to the 6th, v to the 12th. Make sure when you are entering this that you put your numerator in parentheses. So negative 1, k to the power of 6, divided by